So today we're going to talk about security implications of the Pectra upgrade. I'm not sure how many of you already know about the Pectra upgrade. Can I see a raise of hands? Awesome, pretty much everyone. The agenda is, for you and for me. I need to know, and everyone needs to know where we are. We're going to start with, an overview of the Pectra upgrade. We're going to dive deeper into EIP 7702. And finally, we're going to talk about some countermeasures to mitigate the risks that Pectra introduces. So going off of the first part, how many of you know how many legitimate planned upgrades Ethereum has had up to date over the years? Any guesses? No guesses? So it's around 10 planned upgrades if you don't count the hard fork that was caused by the DAO hack. And it's about one per year, except for 2021 where there were 2 upgrades. And starting with the merge, you can see the image there. The consensus client and the execution client have been upgraded in parallel, like at the same time, whenever there's a hard fork. And they have these funny names where they combine the name of the consensus client on this column with the name of the execution client, which is using the names of all the DevCon cities. All right, the Pectra upgrade is one of the biggest upgrades so far. Initially, I think it planned to have around 20 EIPs, which is absolutely crazy. And they boiled it down to 11. And they were discussing which EIPs to include and which to exclude up to the last 24 hours. I'm not going to go over all of them, but I just wanted to give you an overview of what each upgrade does. I'm not sure if it's visible in the back of the room. We're going to dive deeper into number 10 here on the list, which is 7702. But before we do that and we look at all of those security issues that were introduced there, let's look at the core objectives that Pectra had. So it basically intends to enhance 3 pillars. One is the validator efficiency. There's a bunch of EIPs that have to do with improving how validators operate and what they can do. The second one is to boost layer 2 scalability, because there are, as we know, dozens of layer 2 solutions now on Ethereum, and things were getting a bit crowded, also on the network side. And the third one is to improve the user experience vastly. So I'm going to go over a few pros. The first one is for staking and validator enhancements. The EIP 7251 is basically meant to, this was one of the most awaited EIPs, because not only does it allow you to add more ETH to your validator from 32 ETH to 2048 ETH, but it also introduces these compounding rewards. So before Pectra, what validators needed to do was to get their rewards separately, wait for that reward to accumulate, and then create a new validator such that they can earn rewards on their rewards. Now this is done automatically. So if you have a validator which has under 2048 ETH and it earns rewards, those rewards immediately compound and you start earning more rewards on them. EIP 7002 allows validators to exit without needing to coordinate with their infrastructure providers. So you have a lot of custodians that allow you to do staking through another validator, and there was a lot of communication needed between the custodian and the node operator. This no longer is the case when you want to exit, but there's a catch. If the validators get slashed, they get put into a queue, and you as a custodian cannot exit until the 48 days are up. And finally, 6110 allows for faster deposits. This doesn't mean that the validators start earning from days, like before it used to take days to process this deposit. Now it takes minutes, but you still get put into the queue and you might need to wait a few days, depending on how big the queue is. The second pillar, which was the L2 scalability enhancements, is also a big pro, where before you used to have this, this image here, where there was a lot of clutter, a lot of people misusing certain pieces of the infrastructure, like the call data, to put data blobs and so on. You now have increased blob capacity that allows validators to put more data at a cheaper price on the L1. And you have this EIP that introduces some precompiled cryptographic libraries like BLS to significantly reduce the gas costs when you need to process, like the cryptography primitives in ZK rollups. And finally, I think there's a lag with my remote. Yeah. Finally, you have EIP 2935 that stores the recent block hashes that allows, this to be accessible directly in the state. So you can do the verification of proofs on chain, and you don't need to rely on an off-chain service to do that. All right. Cool. Now we get to part 2, which is a bit more tricky, EIP 7702. There's a dilemma here because it introduces a lot of cool features when it comes to UX, but it also creates a lot of pitfalls for unsuspecting end users. And I want to see another raise of hands as to how many people here have had to do an approve and then a confirm when you needed to do anything like swap tokens or deposit tokens. Yeah, pretty much everyone. This was really annoying because both the approval has some gas costs as well as the actual thing you want to do. And another problem that we had here was that when you were approving, you needed to either specify unlimited access to your particular token, like DAI in this case, or you needed to specify an exact amount that you wanted to swap or deposit. And that became annoying. If you were really like security conscious and you wanted to limit the spend, you needed to pay these approval costs, the transaction fees every time. And this was very annoying. This is just one example of where I think most users had to do with multiple transactions instead of being able to batch transactions. What EIP 7702 does is that it grants superpowers to these EOAs, to the wallets. And it does that by introducing a new transaction type. Transaction has this code 4, and it allows it allows every EOA to attach the code of a smart contract to it for a temporary amount of time. I noticed now that there's a single transaction is written there. It's not necessarily 100% accurate. It actually stays bound to the code until you tell it it shouldn't be bound anymore. And the problem that it solves is that now you don't need to do those approval and then confirms. You can do all of that in one transaction. And it basically doesn't force you to migrate to a smart wallet. You don't need to migrate your funds from your MetaMask to some smart wallet that can do that for you. You can just do it from your own wallet, whatever wallet you have. But yeah, and that is a tremendous user experience improvement because you can do, like we just talked about, transaction batching, but you can do more than that. You can do sponsored transactions where you don't need to pay for gas as the end user. You can do social recovery in case you lose your keys and you have like some trusted people in your circle. They can help you recover your keys, and many more passkey signers and so on. And all of this is done by attaching a logic module to your wallet. However, this is where we get to the meaty, interesting, spicy part. there are plenty of new attack surfaces here. And the core vulnerability, if you want to call it vulnerability, is on the social engineering side. So it's not a bug in the protocol itself or anything like that. It's purely creating more opportunities for social engineers to trick users into signing a specially crafted authorization method and stealing their funds. And this is done using a simple signature. It's not even a transaction, but it's just a signature of your wallet where you sign on which chains you want which contract address to be associated with your wallet, and you provide a nonce. So basically, you can even use 0 as the chain ID to specify that you want this on all chains, which is very dangerous, so don't do that. The signature is, it basically grants this contract address mentioned there temporary control over your wallet, and it keeps that control until you specify, okay, it shouldn't do that anymore. Like you want to associate it either to a different contract or you want to dissociate it completely. And this basically creates this kind of deception when it comes to users, because to a user, it might seem like a harmless message that they're signing. They might think it's an airdrop. There were a lot of scams after after Pectra was deployed, where people were thinking that they're signing just a simple airdrop message, and they ended up delegating control to of their wallet to malicious actors, and they got drained. So as I mentioned, this is not a protocol failure. This is as intended. It's not a bug, it's a feature. So we need to step up our game when it comes to wallet security. There are a bunch of threats, new threats when it comes to the wallet level, like when you get this thing to sign, it's just a 32-byte hash. And if it's not decoded by your wallet, you have no idea what you're delegating your wallet to. And this basically needs to happen on the wallet provider side. They need to decode this. They need to figure out, they need to indicate to the end user what are they doing exactly. And attackers can easily hide a malicious call, like set approval for all, within a long sequence of seemingly benign operations. And finally, there's a lot of transaction obfuscation going on where attackers try to overcomplicate what is going on in a certain approval, such that users say, oh, I don't want to check all of this. It's like one of those, terms and agreements thing where I don't want to read through all of this. I don't understand this, so I'll just sign it. And this is where, users get tricked into delegating their wallet to a malicious contract. And part 3, the final one, with regard to the attack surface, is that we have a lot of legacy systems, like legacy wallets, which are not yet prepared for 7702. So I'm going to get to that in the third part, what wallet designers need to do in order to prevent attacks. But one which is really interesting is this init function. Typically, in Ethereum contracts, you might have a constructor that sets up and creates the contract, and then you have an init function that creates, sets some parameters. You would typically write that as separate functions in your smart contract, but the problem is that now with EIP 7702, this init call, which is done after the constructor, could be front-run by a malicious smart contract. So an attacker could, call the init before your, intended caller, and they might get access to the entire thing. And then there's another one which has to do with developers, where typically, historically, everyone was using TX origin, which is the EOA that initiated the call, to distinguish from the message sender, which is the contract that intermediates a call. And by checking that these two are different, you can make sure that you're talking to a contract or not. And now this no longer applies because any wallet can be an actual smart contract. All right, and now we get to the last part, which is also, I think the takeaway. The wallet providers need to step up their security game. So it's their responsibility, in my eyes, to implement a clear, human-readable description of what you're delegating your wallet to. They should explain this in words, human-readable words, and not just hex strings. They need to do transaction simulations such that when you're doing a transaction, before you sign it, they should show you what the net flows are going to be at the end. And ideally, they would integrate some proactive threat intelligence where they blacklist certain contracts that are known to be malicious, and also detect suspicious logic in the contracts that you're trying to delegate to. On the user side, what you can do is to make sure that if you don't understand what you're delegating to, you're not 100% sure, it seems fishy, just reject it. And one thing which is not that convenient, but I think it's the way I'm going to be doing things, after Pectra, is that you have a hot wallet that doesn't have all your funds in it, and you have a, let's say, colder wallet, maybe a hardware wallet, maybe a wallet that you don't use very often. And let's say your cold wallet contains most of your funds, and whenever you want to interact or delegate, you send a part of your funds that you want to do something with to that new wallet, and then you delegate from that new wallet, such that if the funds are compromised, it's only a small part of the funds and not the entire amount you have in your cold wallet. Another countermeasure, which is less popular in terms of like user adoption or mass adoption, is to use something like an MPC wallet where the keys are basically split over multiple entities. And the problem that you're trying to solve here is that the private key, the one that you're signing with, the delegation, is the one that is the single point of failure. So if one user gets social engineered into clicking something by mistake, then you're screwed. So what you want to do is to have multiple parties that have different parts of the key, and then a social engineer would need to trick all of those parties, maybe 3, maybe even more, to social engineer them and trick them into signing the same delegation. One key benefit for off-chain policy enforcement is, in institutional MPC solutions that basically have very complex security policies when these kind of transactions happen. So those are not publicly visible necessarily, and I think like for institutions, this is a less of a problem as for like the mass end users that use something like a MetaMask. The third and final countermeasure is to don't trust anything, right? Just try to validate. As a developer, you should audit your dependencies and you check, if any of those might be vulnerable to front running or storage collision. You also assume that all EOAs could be a smart contract. You can't use TX origin to discriminate between a smart contract and an EOA anymore, and you can't use the code hash to check if the code size is 0, then you don't have you have an EOA. So those tricks don't work anymore. And finally, there are a couple of standards that help you with interfaces for requesting permissions, and this is basically meant to improve the user experience when it comes to this 7702 adoption. In conclusion, we're in an arms race as usual. Pectra brings a lot of power to the user experience, to staking, to L2s, but it comes at a cost of shifting the security burden from the immutable protocol, the reliable and secure blockchain, to the wallet layer, the dApps, and the users, which are more vulnerable. And the path forward, of course, is to use these kind of robust key management, to use MPC solutions, to have like multiple wallets, not all the funds in the same wallet, and you have to have security conscious developers. And that's it for me. Thanks a lot.
Thank you, Albert. Give it up. Perfect timing, right on schedule. So we have 3 questions that came in for you. And I hope everybody's listening. So first one up here on top, how can I check if EOA has a contract attracted, approved, or is that not possible?
Actually, so, sorry? Oh, yeah. Oh, yeah. So if, is it the, oh, it's this. The top one. Is the top? Yeah, okay. So I actually don't know the answer to that question, but I do expect there's a call that you can check whether some wallet has something attached to it, but I don't know what the call is.
I heard about it, but the best thing is, next in just like 10 minutes we have a panel with 5 guys of you with high security within the blockchain. I bet one of you will know. So we can always bring it up at that point after that one.
Definitely.
So the second one, is there a curated list of trustworthiness of smart contracts?
I think every wallet provider has such a list. I know there are multiple solution providers that integrate with MetaMask, like Chain Patrol. They have whitelists of dozens, hundreds, thousands of contracts that are both whitelisted and, they basically use a whitelist. If something is not on the whitelist, they basically consider it as malicious, which can be annoying if you deploy a new contract and they haven't included it yet.
Yeah, because you create a new code, something new, and nothing is there, and they're like, risk.
Yep. Damn it. Yep. So you always need to keep in touch with these providers and tell them like, this is me, please add it because my users are telling me that there's a scam on my website.
One of my colleagues or friends, he just created his own new contract because they had a malicious contract from the market maker, and that was malicious, but it didn't trigger, and they created a new one, so it has, on Token Sniffer, it has a 20 out of 100 because of that.
Because it's new, yeah.
Because it's new.
Yeah.
But they got up to 100 after a few minutes, but still. So the next one we have here, do you think the Ethereum community underestimates the risk of the EIP/7702 going live so quickly after Pectra?
Well, I mean, the EIP was part of Pectra. I think this is a needed risk that we need to take in order to foster mass adoption, because now with this EIP, you can basically have users that don't even know that they're using crypto, onboarding into crypto by sponsored transactions and so on. So it's very convenient for end users, and that was one of the big blockers to mass adoption up to now. So I think I think the community probably underestimates the risk, but it's a risk that was needed. Yeah.
Well, think about it. Every OG that came into the space took a risk on every single transaction they made in a wallet. We still do every day because you never know. Maybe.
Yeah. Yeah.
Well, do we have any questions? Oh, we have Stu down here.
Hey. So, what happens when we change between delegation contracts and storage slots collide?
What happens when we change between delegation contracts?
So, let's say I first delegate to contract 0x1, right? And it uses slot 0 for whatever, but it puts some value in there, right? And then I change the contract I delegate to 0x2, which uses the same storage slot for something else. What happens then?
Well, I think the code itself is the one that is being executed. I don't think it would fail the transaction if it uses the same storage slot. because the assignment is on the contract code. It's not necessarily looking at which storage slot that contract is going to touch.
Okay, thank you.
So we're going to have one final question before we go on to the moderator board afterwards.
Maybe you or maybe somebody from the audience, what wallet would you say does describe the risk of delegating and using the 7702 in like the best way? Like what wallet does the best job in describing the risk and using this feature?
That's a good question. I can't say that I've used all the wallets out there. One thing that I know is wallets like MetaMask, they have just one wallet that is hard-coded into the extension itself, and it only allows you to delegate to that contract such that you don't make the mistake of delegating to some malicious contract. I think that's a good approach. It does limit the way in which you can use this feature. It sort of like sandbox or like boxes you into whatever consensus wants to put into that contract. But I think contracts still are working on that. Do you have any contracts that you think, like any wallets that you think are good at describing this right now? I haven't seen one myself that I would say like this is the right thing to do. But if anyone in the room knows a wallet.
Well, the thing that I dislike the most about MetaMask is that it exposes their entire API structure and all of their variables to JavaScript, which allows people to overwrite the internals of MetaMask using the JavaScript on the page that you're visiting. Whereas systems like Trust Wallet and whatever, Solana's wallet, and I think a couple others, they use a proxy architecture where they're funneling the request to secure memory that the web page can't touch. Yeah. And so I would advise against MetaMask because although it's hard-coded, it can be rewritten using JavaScript. And that's how people were just like browsing Facebook and had all their money stolen out of MetaMask.
Yeah, you shouldn't do a lot of social media browsing with the wallet, with the browser where you have the wallet. Yeah. Try to keep the browser with the wallet only for crypto actions, and social media do it on another machine, ideally.
Like just a hard-coded machine just for the wallet.